This is 4.3, Solving Systems with Elimination, Part 2. We're going to solve systems of equations using multiplication in order to eliminate a variable. We've seen how to solve by graphing, by substituting, and by eliminating. In previous examples, our equations were already set up with opposites. In this case, the 3y and the negative 3y are going to zero out, and it's easier to solve for the x. In order to figure out how to solve systems that don't have opposites set up, we have to look at a single equation first. This equation is actually equivalent to the equations below it. What did I do to get from the dark blue equation to this light blue equation? What did I do to get from the top equation to the bottom equation? I hope you said that you're multiplying by a negative 2. So you can see that this is an equivalent equation. It's exactly the same thing, just rewritten in a way that we can manipulate. So let's go ahead and practice that by rewriting equations so that we can manipulate them to find opposites. I do not have opposite x's. I've got a positive 5 and I have a 10x, which are not opposites. I also have a positive 1y and a negative 7y, but they're not opposites yet. Let's turn them into opposites. So I'm going to multiply this top equation by a positive 7, and that will give me a positive 7y to match my negative 7y. Let me go ahead and rewrite this first equation here. Distribute, so 35x plus 7y equals 63. And I'll rewrite that bottom equation. 10x minus 7y equals negative 18. And now I have my pair of opposites and I can solve. You can see I've solved for x, and I'm going to take that x and I can substitute it back in to either one of the original equations and solve for my y. So I'm going to substitute into the top equation and I get 5 plus y equals 9. Solve for y equals 4. And there's part of my solution, and here's the other part of my solution. So the key piece here is setting yourself up to find those opposites. Taking a look at number 3, I'll have to multiply both the top and the bottom equation by a different number in order to solve for opposites. So for the first equation, let's set up our x's. It would sure be nice if I had a number that both 4 and 3 went into, maybe 12. I could do a positive 12x here, and I could set this bottom equation up to give me a negative 12x. So how do I do that? Let's multiply this top equation by a 3 and the bottom equation by a negative 4. Now I've multiplied both of my equations. Remember, it needs to be a negative 4 so that I have this negative 12x right here. And I've got my pair of opposites, and I can go ahead and solve. I solved for y, and the last step is to solve for x. So I just rewrote this top equation, and I'm going to solve my negative 1, substitute in for y. 4x minus 2 equals 6. And that gives me 4x equals 8. Divide by 4, and x equals 2. So there's part of my solution, and there's the other part. All right, take a look at numbers 4, 5, and 6 and see if you can find some opposites. Number 4 is already set up for us. The opposites are the negative 4x and positive 4x. For number 5, it's awfully close, but 2y is not opposite of 2y. I have to multiply this top equation by a negative 1. So when I multiply the top equation by a negative 1, I can get this pair of opposites with the negative 2y and the positive 2y right here. And then I could add straight down. For number 6, I want to get the x's to eliminate, so what do I need to multiply the second equation by? Well, I multiplied the second equation by a positive 4. And you can see in this pink equation here, 4x minus 12y equals negative 24. And then I just rewrote the second equation, I rewrote the first equation, negative 4x plus 9y equals 9. And now I've got my pair of opposites, and it'll eliminate the x's. There's another way of solving number 6 also. Instead of multiplying the bottom equation by a positive 4, I could set up the y's to eliminate. So to do that, I can multiply the second equation by a positive 3. And this way, when I add straight down, the y's eliminate. If I wanted to continue this problem, I would get negative x equals negative 9, divide by a negative 1. So x equals positive 9, and I could substitute that back in and solve. Either way, you're going to end up with the same solution. So go ahead and try 4, 5, and 6, and then check your solutions down here.